All right, it's day 3 of our experiment to see if the reason one of my milk spoiled was really because it was smaller. And so today I'm going to look at all the data and see if my hypothesis or my idea was right. And when we do that at the end of an experiment, it's called a conclusion. So that's our first vocab word for today. A conclusion is the summary at the end of an experiment. So, as you can see, actually let me show you. Here are our milk samples, and this was the 20 milliliter, this was the 40 milliliter, and this was the 60 milliliter. And they all actually look a little bit different. They've all separated in different ways. But remember, we're measuring the pH level. So the first thing I need to do when I make my conclusion is actually use my data table. This is what we created yesterday. So a great conclusion needs to be substantiated. That means you can't just say, yeah, it looks like this one spoiled the most. No, you need to back it up with numbers. So substantiated means include some evidence from your data table. So if I were to look at my data table, remember, I've got my independent variable in the first column, and then my dependent variables are in the next one. I had a quantitative dependent variable because I have the pH scale in numbers, and I have a qualitative observation of how it smelled. IV first, and then all of your DVs. So when I look at my data table, I see that all of these started around 7, and all of them ended around 6 on the pH scale. So I need to write that in my conclusion. I'm going to show you the sample conclusion. It's going to be a lot of writing today, but that way you get a great idea of what a perfect conclusion has. Remember, the first part, it needs to be substantiated or have that evidence. With 20 milliliters of milk, the pH changed by 1. With 40 milliliters of milk, the pH changed by 1.5. With 60 milliliters of milk, the pH changed by 1. All I'm doing is writing my results from my data table as the first part of my conclusion so that I can have evidence, so that it can be substantiated. The next part of my conclusion is I need to answer the testable question. So based on the results from all this milk, and I measured the pH of each of these all 3 days, is it true that the volume or the amount of milk actually makes one of them spoil quicker? Well, based on my data, not really. They all started at around 7 on day 1, and by day 3, they actually all ended with a pH of 6. So it turns out the volume didn't actually affect the spoilage rate. That's the second part you need to write. The second part of your conclusion should answer the testable question. Do you remember what my testable question was? Yeah, is the volume going to actually matter? My conclusion was that it didn't. Go ahead and write that down. I will read it once, but you can pause the video if you need more time. Therefore, the volume of the milk did not affect the spoilage rate because all 3 volumes changed by 1.0 to 1.5 on the pH scale. Notice I said that it didn't affect it. I answered my testable question, and then I have that explain part, that because. I know it didn't affect it because the 3 volumes changed by about 1 to 1.5. My last part of my conclusion is going to tell if the hypothesis was right, and then I need to say what I learned. So the next part, restate your hypothesis and tell if it was correct. Go ahead and write that down as your next bullet point under your conclusion. Tell us if the hypothesis was correct and restate the hypothesis. I'm going to show you an example of that. So remember, I thought that my little gallon of milk rotted faster because it was little, but it could have been because of the brand, it could have been because of the type. I only tested one, and my hypothesis was wrong. So I'm going to write that right here. My hypothesis was that less volume would spoil quicker. My hypothesis was incorrect. And in science, it's okay to be wrong. In fact, most scientific discoveries happen because someone had a wrong idea about something, but it actually led them to find something new. So it's okay to take chances, to take risks, and oftentimes we'll end up with a new question. Which leads us to the fourth part of our conclusion. First part, we put some evidence in there. We call that substantiating our conclusion. The next part, we use those numbers to say if our testable question was right. The third part was our hypothesis. We needed to say if we were right or wrong and remind ourselves what our hypothesis was. And the last part, well, what am I going to do with this information? So your last part of your conclusion, what are we going to do with our new learning? So you need to connect to the future and tell what you learned. So I had two types of milk, one spoiled, one didn't. That was my observation. And then I had to make an inference or a guess as to why that one milk was spoiling. I guessed it was because it was a smaller container, but that wasn't right. So maybe now I can do a different experiment and see, maybe it was the brand. Maybe that Brown's milk is just not a good brand because it spoils too fast. That could be something I test in the future. For my next experiment, I can see if the milk For my next experiment, I can see if the milk brand affects the spoilage rate. I learned that even a lot of milk can spoil quickly. Feel free to pause if you need more time. So, it turns out that all three volumes of milk are really, really smelly because they all spoiled at about the same rate. And I was able to measure that quantitatively using my pH scale. I still don't know why that little milk spoiled, so the next thing I can test is the brand. Whenever you finish an experiment and you're done with your conclusion, that usually leads you to another wondering question. We just completed a whole experiment in 1 week, and now you should be ready to design your own experiment.